described. So this part is just describing a certain set. And then when you talk about set builder notation, we'll discuss this in details, I think, on the next page or the other page. Yeah, so set builder notation, this is how it looks. It can either also be described inside, or you can use intervals like this part here, even this one. So if you want, you can use intervals, or you can just describe depending with what that set is all about, or the elements that set contains. So the roster form is this form here. So this is the roster form. All right. So the roster form is this one here. And then there's also this form here, which is also a roster form, even these ones here. All right, so let's look at now the finite and the infinite set. So a finite set is simply just a set which contains a definite number of elements. So a set which has a countable number of elements is called a finite set. And then the opposite is an infinite set. So an infinite set is just a set that contains an uncountable number of elements. All right, so yeah, so this is what I'm trying to talk about. So a finite set is a set that contains that has a finite or countable number of elements. And then an infinite set is a set that has an uncountable number of elements. So an example of a finite set is simply A is equal to, you have A, you have B, you have C. So this is a finite set because you are able to count the number of elements. You have 1, 2, 3 elements. Same applies to set B, for instance. If you have, if you have B is equal to, and then you open the brackets, you have B is equal to 1, 2, 3. So this is also a finite set because you are able to count the number of elements that are inside. Yeah, so when you talk about infinite set, so infinite set contains uncountable number of elements. For instance, if you have A is equal to, open brackets, you have 1, 2, 3, then you have dot, dot, dot. So these 3 dots represents infinity. It simply means it has no ending. You're just so this set can also be described using the set builder notation as okay, in short, you can say these 3 dots means an infinite, meaning there's no ending for these numbers, they keep on going. Yeah, so same applies to this set here. So this set I'm going to write here, you can have 2, infinite like this. So this one is also an infinite set because of this symbol here, meaning the numbers are running starting from 2 and then going to infinity, to a positive infinity. Same applies to this set here where I say negative infinity, 3. So here the numbers are running from negative infinity up to 3, but 3 is not part of the set. I'll explain why when we start doing the interval notations. Okay. So I'm going to explain what this means, what this kind of bracket mean, and this kind of bracket mean when we start doing interval notations. All right, so let's proceed. So this is just an example, which is from your handout. I got some of the examples from the handout. So this is an example from there, which is A is equal to that. As long as you are able to count the numbers there, I mean the elements in the set A, B, and C, it means that this is a finite set. And then here you can't count the numbers, I mean the number of elements there, meaning this is an infinite set. Okay. So let us look at the universal set. So what is the universal set? A universal set is simply just a combination of all the given elements or all the given sets. If, for instance, you have set A is equal to 1, 2, 3, and then you also have set B, which is equal to 1, 2, 5. These are the sets that you've been given. To find the universal set, you just have to add the two sets without repeating the common numbers. So if you have 1 and 1 in both sets, you don't have to write it 2 times. You just write it once, 1, and then you have 2 and 2 there, you write it once. Then you have 3 there, then you have 5. So you don't have to repeat common elements. Yeah, so that is a universal set. Yeah, so that is a universal set, right? So that is what this statement means. That is what that statement means. Okay. Right, so this one I've explained. And then what is a power set? So a power set is simply just a set that contains all the, it's a set that contains all the subsets, yeah. It's a set that contains all the subsets. We're going to talk about the subsets, and then I'll get back to the power set. Yeah, because I know you can't understand the power set if you don't know what subsets are. Okay, so when we talk about a subset, I'll come back to the power set. So just know that a power set is simply just a set of all subsets of a given set. So if, for instance, you've been given set A is equal to, maybe 1, and then you have 2. So the subsets of A, if you list the number of, if you list the subsets of A, so we do this, and then we list the subsets of A. The first set that is in A is an empty set. So an empty set is a member of all subsets. Is a subset of all sets. So the first subset that we have for this set A is simply just, so what I'm listing here is simply just a power set of A. So an empty set, if you want, you can represent it using this. You can present it using this, or if you want, you can present it. You can present it using this. Yeah, so that is an empty set. And then the second set that we have is simply just 1. The third set, this one here, the third set that we have is simply just 2. And then the other set that we have is simply just the same set. So set A is a subset of set A, because we know that A is found in A. All the elements in A are in A. Okay, so this is what we have. So let us write the other set. Okay, so these are the subsets of set A. So this set here is the one that we are calling, this set is the one that we are calling the power set of A. So a power set is simply just a set of all subsets of a given set. Okay, so that is what I was just explaining. Then let's look at the equality of sets. So we say two sets are equal if they have the same number of elements and the same elements. So if two sets are equal, they should have the same number of elements and they should contain the same elements. So if for instance we have set A, which is A, B, C. So for set A to be equal to set B and set A should contain the same number of elements and the same elements. So set A, we can say set A is equal to set B. So for two sets to be said they are equal, it means that set A and set B have the same number of elements and they also contain the same elements. But for two sets to be called or to be termed to be, if two sets are equal, they should have the same elements, the same number of elements and the same elements. And then if two sets are equivalent, means that they only contain, they may contain the same elements and the same number of elements, or they may contain different elements, but same number of elements. So what I mean is that if we say the two sets are equivalent, okay. I don't know the name, but it was just brought TechnoSpark 7. Okay, what's your question?
So there's someone who's texting me and said he has paid through MTN, but his WhatsApp line is Airtel. He's failing. I've given him the code, but he's failing. So maybe you are supposed, I don't know what you're supposed to do. But they said he has paid.
Texted me?
Yeah. Okay, let me tell him to text you now.
Is it Richard?
No, Geoffrey.
Okay, let them text me. All right, so I was saying if two sets are equivalent, it means that, let's take for instance, we have set A, which has A, B, C, D. So set A can be said to be equivalent to set B if and only if they have the same number of elements. So they may have the same, they may have different elements, but as long as they have the same number of elements. So let me just say this is 4. Okay, 1, 2, 3, 4. Then we have A, B, C, D. So as long as they have the same number of elements, we can say the two sets are equivalent. Yeah, the two sets are equivalent. Okay, let's proceed. So feel free to ask questions if at all you don't understand anything or if you miss any point. So this is what I was just talking about. In case of, maybe in case you want to read on your own, I'll post this slide in the group immediately we are just done, together with the video. All right, so this is what I was just talking about.
Sorry, sir, before you proceed.
Okay.
On equivalent sets, you said, I missed the point, you said, for as long as they have the same number of elements, even if they are different, but for as long as the elements are the same, they are equivalent.
Yes. Yeah, so that's why I've put up this point here. Let me just write it. So if you have the same number, if you have the number of elements in A, okay, this point here. Let me just get back. Okay, so this one here. So the number, if the number of elements in A are equal to the number of elements in B, means that the two sets are equivalent. If the number of elements in A are equal to the number of elements in set B, means that the two sets are equivalent. Okay. So let's look at discrete and continuous sets. So this is just the same as what I've just been talking about. The sets that we've been discussing from the time we started are discrete sets, and then continuous sets are simply infinite sets. So this is what I was just talking about. I don't even have to explain a lot here. So this is what I'm talking about. So when you say numbers, the number of elements between 1 and 0, this is a continuous set because you can't manage to count the number of elements between 1 and 0. You have 0.001, 0.002, 0.01, 0. All those numbers inclusive. So you can't manage to count them. Hence, it's a continuous set or it's an infinite set. Okay, so this is what I was talking about. So this set here can be written as, okay, there was a mistake here. I'll explain why I'm saying there was a mistake. And I got this straight from your handout. These are the brackets that are supposed to be used here. Okay, So let's proceed. So even this one, this is a continuous set. Yeah, it's a continuous set. So let me just explain this in advance, maybe. Instead of me just, I'll explain it, just saying I will explain it later. So if you have this kind of brackets, it means that the numbers 0 and 1 are also part of the set. But if you have this kind of brackets, it means that 0 and 1 are not part of the set. So if you have this, if you have 2, 3, you have this, it means that 2 and 3 are part of the sets. But if you have 2, 3 written in this format, it means that 2 and 3 are not part of this set. You're just talking about numbers between 2 and 3. And if you have something like this, 2, 5, it means that 2, since on 2 we have this type of a bracket, it means that 2 is part of the set, but 5 is not part of the set because of the kind of a bracket that we have. There's an open bracket. So these two brackets are called closed brackets, and then these are open brackets. So this side we have an open bracket, meaning 5 is not part of the set, and then this side we have a closed bracket, meaning 2 is part of the set. Okay, so let us now look at, we just talked about, okay, we just talked about the notations in which you can write the sets. We never looked at them in details. So we've discussed the roster, which is in this format. We've also discussed the interval notation, though not in details. For this one, we have to go in details. We even start drawing number lines on this type of sets. Same applies to this one. Same applies to this one. So all these three are intervals. This one is in roster notation. Okay, so that is simply how you do assist. Okay. So let us now write these sets in, we write these sets in set builder notation. So this is how you write the first set. You just say set A is such that, set A is equal to X is such that. This line can sometimes, some people use, in some books they use dots, 2 dots. They say A is equal to, then they say X is such that. You write 2 dots like that, and then 2 dots, and then you say X is equal to, you write the numbers of the set. So you have 1, 2, 3, 8. So the reason why they just had to list the numbers, or rather the elements of that set, is because you don't have a specific term that can describe these sets. But if at all maybe these were just natural numbers starting from 1 going up, we would have said where X is a set of, is a member of natural numbers. If, for instance, we had something like this, if this wasn't 8, if maybe this part was 4, if we had something like this, A is equal to 1, 2, 3, 4. So if we had something like this, yeah, so I'm delaying a bit because there are people that are just calling me right now that they need to be added to the group. Let me just add this one, then we proceed. Okay, so if you have a set like this one, if you have a set like this one, and then you want to, you've been taught to write it in set builder notation, you know that this set is a set of natural numbers. We know that natural numbers are simply just counting numbers starting from 1. So we can write this in set builder notation as A is equal to, you open the bracket and then you say X is such that X is X is a member of natural numbers. X is a member of natural numbers. And then you say where, this comma means where X is less than 5. Or if you don't want to use less than, you can say less or equal to 4, because they're just ending at 4. counting numbers starting from 1 up to 4. So you can just say X is a member of natural numbers where X is less than 5. Is still okay, still fine. Okay, but in this case, they have skipped some numbers in between. So you can't just say it's a set of natural numbers. Yes, they are natural numbers, but they have skipped 5, they have skipped 6, they have skipped 7. Yeah, okay. So let us look at B. So we look at B. B is Y. Okay, B is here. So we have B as 0. It's open at 0. It's also open at 2. Meaning we're using this kind of what's this, a sign. We're using less than. If it was closed, like the way you have, it's closed at 0 and then open at 2. Where it's closed, you simply use this type of a bracket here. I mean, sorry, this type of a sign. Where you say, if for instance, this one we can say, when written in set beta notation, we're going to say B, I mean, this B is equal to, and then we say, we can either use X, Y, Z, any letter. So let's use, okay, here they are using Y. So let me just use X. We can say X is such that X is such that X is a member of what? Real numbers. So whenever you're dealing with intervals, I'll explain it in details. Whenever you're dealing with intervals, you need to understand that you're dealing with real numbers only. If you're dealing with intervals, means that you are dealing with real numbers only. Yeah. Okay. Let me just go back. All right. So if you're dealing with intervals, means that you're dealing with real numbers. So this is what you're going to have. It's a member of real numbers, and then where, so these real numbers are ranging from 0, less X, less 2. Then you do this. So that is what you do. Okay. Someone again is calling me. All right. Okay, so please just tell everyone who those people are calling, let them just be texting me. I'm adding them to the group as they are texting me. Okay. So this is how you can write it. This is the other way you can write it, as an interval. Yeah, so which is just the same as this. Here they just used Y, and then they never just showed that it's a set of real numbers. So in other words, they assumed that you knew that when you're dealing with intervals, you're dealing with real numbers. Same applies to this one. So this one, when you look at the bracket that has been used here, it's a closed bracket. That's why they have used less or equal. They have introduced this equal symbol down under the less than symbol. So if the closed bracket is on 2 like this, they will simply okay. We are now disturbed. All right, so he called me using my WhatsApp. So, okay. All right. So let all those who are saying no, they have paid, I've not added them to the group. Let them just text me direct. I'll be sending them the link directly. Okay. So okay. Let's now look at what a subset is. So when we say A is a subset of B, it means that A is found in B. When you say A is a subset of B, it means that A is a part of set B. Yeah. here. So an example is here. Let us look at these examples from your handout. So if we say set A is equal to ABC, and then when you look at B, if you look at B, you find that it also contains ABC, which is set A. It means that A is a subset of B. It means that A is a subset of B. All right. And then same applies to this one. So here, if set A and set B are equal, meaning they have the same number of elements and the same elements, it means that A is a subset and it's also equal to B. Then if you have such a set, you have numbers ranging from 0 to 1, but not including 0 and 1. It means, and then you have this, it means that A is a subset of B. Why do we say that? Because we know that these numbers here, this set here, this set contains 1. This one does not contain 1, meaning it contains numbers between 0 and 1. So numbers between 0 and 1 can also be found in this set, because even this set contains numbers between 0 and 1, but this set also includes 1 as a member. So even this one, we can say set A is a subset of set B, because we're talking about numbers between 0 and 1. That is set A. And then here we're talking about numbers between 0 and 1, but also 0 and 1 are included in set B. So meaning set A is also in set B. Set A is just between 0 and 1 as well. Okay. So we have this other set, we have, so this one is in the roster form. So in this set, we only have 2 elements, but in this set, there are a lot of elements. You can't count this in the number of elements in this set, meaning the numbers, meaning this set is not part of this set. Of course, in set B, we have 1, in set A, we also have 1, but in set B, we don't have 0. Set A contains 0, but set B doesn't have 0. So this is what it means. We don't have 0 in this one, but here we have 0. So if we had this kind of a bracket here, the one that is on 1, if it was also on 0, we would have said A is also part of B, which is just this one, number 4. It's the one I'm talking about. But in this case, they used a roster format of representing sets on A, meaning in set A, we only have 2 elements, and then in set B, we have a lot of elements. This one is a finite set. You can count the number of elements in set A. We have 1, 2, but set B has an infinite number of elements. You can't count the number of elements in set B because we have numbers between 0 and 1, meaning you have 0.1, 0.001, 0.00005, 0.0000. You can't manage to count the numbers that are between 0 and 1. So set A is not a subset of B. Okay. So let's proceed. So if this meeting ends, I'll send another link so that we finish the slide. Okay, let's look at the Venn diagram. So the Venn diagram is just another way of representing sets. Yeah, which is in this format. So the objects that are in this on this part, I don't know if this is yellow color, but the objects that are in this section, simply just so the objects that are in this section are simply just elements that are only in A. They are only in A. And then the objects that are between here are in the intersection, meaning they are both in A and in B. The objects that are this side are only in B, but not in A. So the union set, when you talk about the union set, we're simply talking about the combination of sets. So when we talk about union set in mathematics, we're talking about the addition of sets. Yeah, so we're talking about the addition of sets. So union set is simply just the addition of 2 sets. Yeah, okay. So for instance, if you have set A, which is 1, 3, 5, 7, and then you also have B, which is 1, 2, 4, 6, 7. So A union B would just be the combination of two sets. Of course, when you're combining these two sets, if you have common elements, you don't have to list them 2 times. You just have to list it once. For instance, we have 1 there. We also have 1 there. Meaning when listing this side, the A union B, you don't have to list it twice. You just put it once there. And then you also write the other elements as they are. You don't have to list the common elements 2 times. So when this link finishes, I'll send another link in the group. Okay. So when you talk about the intersection, we're just talking about 2 common elements. Yeah. So when you talk about intersection, we're just talking about, common elements in set A and in set B.
So let's try to talk about the laws that we need to understand under set theory. Basically, the first law that is very important, or